Solving trigonometric equations is the topic of this lesson, and we'll solve two equations, and this will hopefully give you an idea of how to solve both single theta or single angle equations as well as double angle equations. Let's take a look at this question here. So it says solve for theta given 2 cosine squared theta minus 5 cosine theta equals 3. And we're given a restriction that theta must lie between 0 and 360 degrees. Okay, well, you might notice right off the bat this has a squared in it. So this is degree 2, making it a quadratic. And we know that to solve quadratics, a good idea is to move everything over to the one side, set the right side equal to 0, and then we can apply factoring. We could, if we wanted to, use the quadratic formula. So we have a number of different tools at our disposal to solve for the roots of a quadratic. The first thing I'm going to do, though, is I'm just going to rewrite this with the 3 moved over. So I'll say this is the exact same as 2 cosine squared theta minus 5 cosine theta minus 3 equals 0. Okay? Now, that looks a lot like a quadratic, doesn't it? So I'm just going to say this looks like 2x squared minus 5x minus 3 equals 0. Okay? Now, if you were to factor that, and I'm not going to go into how to factor that, there's other videos on factoring, this would factor nicely into 2x plus 1 and then x minus 3 equals 0. Okay? Well, once we've done that factoring, we can go ahead and replace these x's back with cosine theta. So that leaves me with 2 cosine theta plus 1 and then cosine theta minus 3 equals 0. Okay? All right. Well, if we take a look at this root here, we are looking to see when 2 cosine theta plus 1 equals 0, or when does cosine theta equal negative 1 over 2. If I put that into my calculator, then it will come back and say, oh, okay, your angle is 120 degrees. Now, there is another possibility, because we know from our cast rule, and I'll very quickly do the little cast rule here. Our cast rule will identify where the cosine ratio is negative. And we know that the cosine ratio is negative in quadrant 2 here. And in fact, there is our 120 degree measure. And sure enough, cosine is negative there. Our cosine theta was negative 1/2. Okay, well, what is the related acute angle here? And we can see that it is 60, because 180 would require 60 in here, because 120 plus 60 is 180. Okay, to find the second angle, we're going to ask where else is cosine negative. And it's negative down here in the third quadrant. So if I put another terminal arm there, and if I include the same related acute angle of 60, well, then the angle starting from here and terminating here is actually 160, or rather 180 plus 60, or theta equals 240 degrees. Okay, so those are the two answers, and they do fall within the range of 0 to 360 for this first factor. Alrighty, well, let's take a look at the second factor. The second root says we need to find out when cosine theta minus 3 equals 0, and that is, when does cosine theta equal positive 3? Well, this one here has no solution. Okay? And why is that? Well, your calculator will tell you if you try to take the inverse cosine of 3, it will give you an error. But we know that the cosine ratio falls between positive 1 and negative 1. Okay? And it will never be able to equal 3. So this side of the equation has no solution. All right? So that makes our final answer to this. It says solve for theta given this equation. Well, these are the only two answers that match that equation. All right, let's take a look at another example. In this example, we're asked to solve for theta given 2 cosine 2 theta equals 1, and we are given a restriction that theta must be between 0 and 360. All right, well, as soon as I see a double angle that is right there, instead of just theta, I've got 2 theta. Well, the first thing I'm going to do is I'm going to say that 2 theta would have a restriction that is not 360, but it is twice the restriction of theta, which would be 720. So that is my restriction on solving for 2 theta. Okay, well, how do we solve this? Well, notice that in this case, there is no squared. There's no quadratic. So I don't need to gather everything over to the one side and then try and use skills like factoring or use a quadratic formula. I'm just going to solve straight away for 2 theta. So if I write this as 2 cosine 2 theta equals 1, I can then say, all right, the cosine of 2 theta equals 1/2. And then I can say, what is 2 theta? So 2 theta will be the inverse cosine of 1/2. And if you put that into your calculator, it will tell you that 2 theta is equal to 60 degrees. Okay? Well, if I draw a quick little grid here, 60 degrees is in the first quadrant here, right there. And my cast rule tells me that that is, where all of the ratios are positive. And I'm dealing with a cosine ratio of positive 1/2. So 2 theta is 60. Well, where else is cosine positive? Well, cosine is positive down here in quadrant 4. So if I was to put another terminal arm here in quadrant 4 and give it the same 60 degree related acute angle, then the second possibility would be starting from 0, going all the way around to here, would be that 2 theta equals 300 degrees, because that angle measure is 300. Okay, so I've got 2 theta equals 60 as one solution, and 2 theta equals 300 as a second solution. Well, are we done? Well, and the answer is no. The reason why we're not done yet is because of this restriction over here for 2 theta. It says that 2 theta is allowed to go up to and include 720. So if we look at our original diagram here with 60 degrees and then 300 degrees, well, there is another angle that is coterminal with 60 degrees. If I had a 60 degree angle here, then I can find another angle that shares that terminal arm by going around one complete revolution and then stopping at that terminal arm. And that would be 2 theta equal to the original 60 plus another 360, which is 420 degrees. Okay? Now, what about the purple one here? Well, again, that had a terminal arm down here in the 4th quadrant, right there, and its original measure was 300 degrees. Well, if I start at 0 and I go 1 complete revolution and then around again, stopping at that terminal arm, I get 2 theta equals the original 300 degrees plus another complete revolution of 360, making it 660 degrees. So let's just summarize those answers that we have. We had 2 theta was equal to 60, 300, 420, and 660. And that means that theta equals 30, 150, 210, and 330. There are 4 possible values for those degree measures. And I'll just put in little degree symbols so we don't lose technical marks. And there we go. So the final answer is solve for theta, given 2 cos 2 theta equals 1. Well, there are the possible values for theta that solve this trigonometric equation.